Alrighty, so we're going to solve exponential equations with the same base. But the first thing we want to do is go ahead and fill out some charts that we're going to be using for the rest of this unit. Part of it's going to be in fraction form, part of it's going to be in decimal form, and the rest of it's just going to be in whole numbers. So we just need to review, how do we write negative exponents as fractions, and how do we get our decimals? So 2 to the negative third is, once again, you put it over 1 and you change the position. So this becomes 1 over 2 to the third. And 2 to the third is 8. So this is 1 over 8. So that's our fraction form. And if we need our decimal form, you can divide 1 by 8 and you would get the decimal of 0.125. All right, next one is 2 to the negative 2. Put it over 1, change places. That becomes 1 over 2 squared, which makes the exponent positive. And 2 squared is 4, so our fraction would be 1/4. And our decimal would be 0.25. That should be a pretty common decimal for you, I hope. Next one is 2 to the negative first power. Put it over 1, switch places with it. It becomes 1 over 2, or 1 over 2 to the first, which is simply 1/2. Decimal is 0.5. Now the next one, anything to the 0 power is always 1. 2 to the first power, anything to the first power is whatever the number was to begin with. 2 to the second power, or 2 squared, is 4. Put it in your calculator. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. And 2 to the sixth power is 64. And if you remember on our calculators here at school, and if you put up the one that is accompanied on your screen, you should put in exponents like 2 squared as 2, and then this little button, and then the 2, and enter, and it should give you 4. 2, this button, and 3 would give you 8. 2, and this button would give you 2, and that button and 4 would give you 16, and so forth. Okay, next chart. 3 to the negative third power. So once again, if you put it underneath 1, it's 1 to the third power, and 1 to the third power is 1 over 27. This would give you a repeating decimal. Most things divided by 3 will give you a repeating decimal. And this is 0.037. The way you denote a repeating decimal is by the bar over it. 3 to the negative 2 is 1 over 3 squared. 3 squared is 9, so it's 1/9. This repeating decimal is 0.1111 forever, so we'll just put a 0.1 with a bar over it. 1 over 3 to the first is just 1/3. And hopefully you guys are pretty familiar with that. It's a 0.333 forever and ever. And you'd put a bar over it. Anything to the 0 power is 1. Anything to the first power is what it was to begin with. 3 squared is 9. 3 to the third is 27. You can look at the denominators right here and see. 3 to the fourth power is 81. 3 to the fifth is 243. And 3 to the sixth is 729. You want to make sure you have this chart filled out because it's going to be very, very helpful on tomorrow's lesson as well. Very helpful. Then we're looking at our 4 base to some sort of power. 4 to the negative third is 1 over 4 to the third, which gives you 1/64. If you divide 1 by 64, you get a crazy decimal of 0.01565. 4 to the second, or negative 2, is 1 over 4 to the second, which is 1 over 16. And you get a decimal of 0.0625. 4 to the negative fourth, or 4 to the negative first is 1 over 4, which is just 1/4. And hopefully you know this decimal of 0.25. It's a quarter. Anything to the 0 power is 1. Anything to the first power is whatever it is. In this case, it's 4. 4 squared is 16. 4 to the third power is 64. 4 to the fourth is 256. 4 to the fifth is 1024. And 4 to the sixth is 4096. All right, we're doing the fifth powers. 5 to the negative third is 1 over 5 to the third, which gives you 1/125th. And this decimal is 0.008. 5 to the negative 2 is 1 over 5 squared. 5 squared is 25, so this is 1 over 25. And our decimal is 0.04. 5 to the negative first is 1 over 5 to the first, or 1/5. And I'm pretty sure this is in your assignment today, so the decimal equivalent would be 0.2. Anything to the first power is 1. Anything to the 0 power is 1. Anything to the first power is whatever it was. 5 squared is 25. Hopefully you know your perfect squares. 5 to the third is 125. 5 to the fourth is 625. 5 to the fifth is 3,125. And 5 to the sixth is 15,625. Alrighty, so we're going to do a little pre-activity. It says rewrite the following of these following things in 2 different ways. One of them should have a positive exponent. Well, if we look back at our chart, we're looking for something that has a 32 as a result. So if we look back up here, we're looking for a 32, nothing in the 5s, nothing in the 4s, nothing in the 3s, but right here, 2 to the 5th power is 32. So we will go back down here and write as 1 over 2 to the 5th power. That's a 2. And if we bring it back up to the top, it makes it a negative power. So this is also equivalent to 2 to the negative 5. But remember, it says one of the ways we rewrite it should have a positive exponent. Alrighty, number 2, if we put this over 1 and we change places, then this becomes 1 over 2 to the 6th power. And if we look back at our chart, 2 to the 6th power is 64. So this is an equivalent fraction of 1 over 64. Number 3, and we're looking for something with the 16. So let's go back up to our chart. 4 squared is 16. And if we look a little farther, we can also see that 2 to the 4th power is 16. So we have 2 options. 2 options. So the first option we came to was 1 over 4 to the 2nd power. And the other one that we came up with was 1 over 2 to, I already forgot, let me go back and see, 2 to the 4th power right here. That is also 16. So 1 over 2 to the 4th power. So those are both ways we can write it. And we have to include at least one of them because they're a positive exponent. 3 to the negative 3. Once again, put it over 1 and change places. So this would become 1 over 3 to the 3rd. And this is also equivalent of 1 over 3 to the 3rd. Well, 3 to the 2nd is 9, and 9 times 3 is 27. So it should be 1/27. So there's 1 in 2 ways. So let's go back and think and see if we have anything that equals 36. We might actually have to think about this one. I don't believe I put anything that equals 36 in the chart. Okay, well, let's think about our powers. There's nothing 2 to any power would give a 36. There's nothing that's 3 to any power that would give us a 36. Nothing with 4 to a power that would give us 36. And clearly nothing to a 5th power, because that would always have to end in a 5. or possibly a 0. So let's think about our 6. 6 to the first power is 6, but 6 to the second power is what? And I hope that you told me it was 36. So this can be written as 1 over 6 squared. And if we bring that to the top, then it would be 6 to the negative 2 power. So there's one way to write it and a second way to write it. All right, number 6, we put it over 1 and switch places. So this is 1 over 8 squared. And if you put 8 squared in your calculator, you would find out that it's 1 over 64. All right, so this is very important that we can do this kind of a thing, especially for tomorrow's lesson. So we want to keep track of these notes after you've downloaded them and wrote on them. For today's lesson, you're going to do problems 1 through 10 on the assignment 1 through 10. Now, if you don't want to enter them in Canvas, you'll need to use decimal equivalents if you do that, because fractions it won't accept. But you're just doing problems 1 through 10, all right? Okay, we are looking for like bases. And all of these are like bases today. That's what we're doing. We're solving exponents with like bases. So these both have a 2, so those are like bases. Bases are the big numbers. On number 2, 4 is our like basis. Number 3, 3 is our like base. Number 4, we have like bases of 2 again. Number 5, we have like bases of 9. And number 6, we have like bases of 2 again. So if we have like bases, then we can just set the exponents equal to each other and solve a very simple little equation. We should be experts at solving equations now that we're in 9th grade. So all of these exponents can be set equal to each other and we'll solve very simple equations. So on number 1, we would have a negative n, or a negative 1n equals a negative 3n. Alrighty, to get all of our n's onto one side, and I like mine positive, and I usually like them on the left, I would simply add 3n to both sides. Negative 3n plus 3n leaves us with 0, and negative 1n plus 3n is a positive 2n. Then we would divide by 2, and we would get n equals 0. So this would be our answer. That's what we're going to enter into Canvas. Number 2, we're setting our exponents to equal to each other again. So 2n minus 2 equals, in this case, it's just a 2. Well, alrighty, solve them like we did when we were in 7th grade. The opposite of negative 2 is to add 2. So those go away, and I have 2n equals, 2 plus 2 is 4. The opposite of multiplication is to divide, so we divide both sides by 2, and this gives us n equals 2. So that's our answer. So you just enter a 2 into Canvas if that was your result. Number 3, our exponents are negative 3m, and on the right-hand side, it's just a little 4. So this is just a one step. So we would look at this and say, oh, that's multiplication. The opposite of multiplication is division. So we would divide by a negative 3. And this would give us negative 1 point, and it's a repeating decimal. So you would put, it goes on forever. But in our Canvas, we would just put this, negative 1.3. There's no way for me to enter a bar over it, because technically we would put a bar over the 3 that repeats. But in Canvas, you would just enter negative 1.3 if that was your result. Number 4, we're setting our exponents equal to each other again. So 1 minus x, and I'm going to put a little 1 right there in front of the x. And on the right-hand side is just 3x. So I'm going to add 1x to both sides. Those go away, and I'm left with 1 equals 3x, and another 1x is 4x. The opposite of multiplying by 4 is to divide by 4. And so this would give us x equals 1/4. Now in Canvas, it's not going to allow you to enter a fraction. So to get our decimal equivalent, it's 1 divided by 4, which gives us x equals 0.25. So that's what you enter in Canvas. All right, number 5. Our exponents are 3n minus 1 equals, and on the right-hand side, it's 2n minus 2. All right, I'm going to go ahead and subtract 2n on both sides. So that goes away. 3n minus 2n is just n. And we still have the minus 1, so bring that down. And it equals, remember this is a negative 2, it equals a negative 2. So we will add 1 on both sides. That goes away. Negative 2 plus 1 is a negative 1, so your answer on Canvas would be a negative 1. And the last one, our first exponent is 1 minus 2b equals, and on the right-hand side it's 3b plus 3. Alrighty, I like to have positive variables, so I'm going to add 2b to both sides. That goes away and I'm left with 1 equals, whoops, I lost my b, sorry about that. And on this side, 3b plus 2b gives me 5b, and I still have the plus 3. Alrighty, the opposite of a positive 3 is to subtract 3 on both sides. 1 minus 3 is a negative 2 equals 5b. The opposite of multiplying by 5 is to divide by 5. And I get b equals negative 2/5. So in Canvas, it won't accept a negative 2/5. So I need the decimal equivalent of that. So 2 divided by 5 is 0.4. And remember, it's a negative 0.4. So in Canvas, you would put negative 0.4. Canvas, you would put negative 0.4. Alrighty, so today's the easy lesson. On Tuesday, it's going to be a little bit more difficult, but you do need to keep this set of notes. All right, good luck. Bye.